Jai Hind everyone. My name is Rinki Tyagi, working as an assistant professor in IT department in Akgec Engineering College. Today is my third lecture video on computer organization in architecture. Today we are going to discuss about complement of a number. Why we are doing complement, what is the purpose of doing complement, types of complement, how subtraction can be done using complement of a number. This is a very interesting topic. It is somewhat theoretical or numerical, but it has a great weightage as when you are going to implement Booth's algorithm, or whenever you are going to do binary multiplication, whenever you are going to do adding any number, then or subtracting any number in computer. Subtraction also done through addition. So complement of a number is very helpful on that part of. Complements basically are used in digital computers. Basically where they are used, there are digital computers. In only digital computer we will use complement technique for facilitating the subtraction operation. As I told, for subtraction operation we do complementing the number. There are different types of complements we will study later, and for logical manipulation. So for logical manipulation also we need to do complement of a number. There are two methods of complement. This is there is r-1 complement and second one is r complement. What is r here? R is basically here a radix. R is radix, or you can say that r is the base here. So r is the radix. Like when we have a binary number has base 2. So r is equals to 2 here. So we have a decimal number system. On decimal number system we have base 10. So here r is 10. So we are going to do 1's complement of a number, 2's complement of a number, 9's complement of a number, 10's complement of a number. So 2's complement and 10's complement of number comes under r's complement. So r's complement here will consist of only 2's complement and 10's complement. But what about r-1 complement? When we minus 1 from the base, so 2 is the base here, 2 minus 1 is equals to 1. So we will get 1's complement. Similarly, 10 minus 1 is equals to 9. So we will get here 9's complement. Similarly, for octal number, we will have 8 minus 1, that is 7's complement, and for hexadecimal, that is 16 minus 1, that is 15's complement. That all comes under r-1's category, and the base, that is 2, binary base, that is 2, decimal base, that is 10, hexadecimal base, that is 16, and octal number base, that is 8. That comes under r's complement. So first we will understand what is 1's complement. Basically 1's complement of a binary number is another binary number. When we will do the complement, 1's complement of a binary number, then the result will be the another binary number. There is no change in the number format. It will be in binary number obtained by toggling all bits in it. What is the meaning of this? Let us understand that we have a binary number like 0, 1, 1, 0. This is the binary number here. This is 0, 1, 1, 0, and we want to do the 1's complement of this particular number. So what will be the 1's complement? 1's complement will be equal to that 0 will be converted to the 1 and 1 will be converted to 0. So this 0 will be converted to 1, this 1 will be converted to 0, this again 1 will be converted to 0, and this 0 will be converted to 1. This will be the result of our 1's complement. So here example is also given that 0, 1, 1, 0. So when we will do the 1's complement of 0, 1, 1, 0, 1 will be converted to 0, 1 will again be converted to 0, again 1 will be converted to 0, and then 0 will be converted to 1, and we will get 1,000 in our result. Again 1's complement of 1, 1, 0, 0. Again we will change the bit from 0 to 1, 0, 0 to 1, 1 to 0, and 1 to 0. So we will get the result here, that is 0 0 1 1. That's all about ones complement of a number, and that comes under r minus 1 category. That comes under r minus 1 category. Second is 2's complement of a number. This comes under r's complement. This comes under the category of r's complement. Simple. There is a little bit change when we will do the ones complement of a number and we add 1 to ones complement, then we will get 2's complement. So basically, if I want to write here, 2's complement of a number is equals to 1's complement plus 1. When we will add 1 to the 1's complement, we will get 2's complement. So it is written here, added to the 1 is added to the 1's complement binary number and we will get the 2's complement. 2's complement representation of binary number, the MSB bit represents the sign. So the MSB bit here, this is the most significant bit. The leftmost bit will be the most significant bit. So this is the MSB bit. So this MSB bit always represents sign. With 0 it is a plus sign. When the MSB bit is 0, it is positive. The number is positive, and when the MSB bit is 1, the number is negative, and the remaining bits are used for representing magnitude. Example of 2's complement, like we have a number here 0, like we have a number a is equals to 0 triple 1. We have a number here that is 0 triple a 1. So first we want to do the ones complement. So ones complement will be equal to 1 will be converted to 0, 1 will be converted to 0, 1 will be converted to 0, and 0 will be converted to 1. Now what about the 2's complement? When we will add 1 to the ones complement, we will get our result, that is 0 1 1 0 0 1. We will get our result as 1 0 0 1. So this will be our result. This is given here 1 0 0 1. So that's all about 2's complement. Now moving to the next topic, that is subtraction using ones complement. How a number can be subtracted using ones complement. As we already studied about that, it is done for subtraction or for logical operation simplification. So how a subtraction can be done using ones complement? So basically there are some steps, like we have a two numbers here, that is, this is number A, this is number B. We have two numbers here, that this is number A and this is number B. So when we see in decimal, 0 triple 1 is represented as 7 in decimal, and B, that is 0 1 1 0 is represented as 6 in decimal. So what will be the ones complement? Subtraction using ones complement. First we will calculate the ones complement of B. The value of B is 0 1 1 0. When we will calculate its ones, it will be 0 will be converted to 1, 0 will be converted to 1. 1 will be converted to 0, again 1 will be converted to 0, and 0 will be converted to 1. So we will get ones complement of B is 1 0 0 1. Then the next step will be, we will add ones complement of B to A. When we want to do the subtraction, simply we will convert the number into the ones complement, twos complement, nines complement, tens complement. Then we will use the adder. In our next lecture videos, we will always also study adder, how adder is working and why only adder is used in binary number system. So for subtraction purpose also we use adder here. So basically we are adding, not subtracting. We are adding, and for subtraction here we are using ones complement. So A minus B, what is the value of A? A value is 0 triple 1 and minus B. माइनस बी यहाँ पे किसके इक्वल हो जाएगा? वंस कॉम्प्लीमेंट ऑफ बी. वंस कॉम्प्लीमेंट ऑफ बी एंड वंस कॉम्प्लीमेंट ऑफ बी माइनस बी. What will be the ones complement of B? Ones complement of B is 1 0 0 1. We will add both the numbers. Again, when we are adding binary numbers, 1 1 is equals to 0 and carry is 1. 1 1 0 0 0 0 and carry is 1. Again 1 1 0, carry is 1, 1 1 0 and again we get the carry 1. So we have a number here in 4 bits, 1 2 3 4, but in result we are getting 5 bit. So this fifth bit is the carry bit. This fifth bit is the carry bit. So in subtraction using ones complement, we will add this one bit to the result here. So what we will do, as a carry bit is generated, we add this carry bit to the remaining result. We will add this carry to the result. What is our result? 1. So 0 1 1 0 0 0. We get 0. So in decimal also, when we want to do 7 minus 6, we get 1 as our result. Here MSB bit is 1, so the number is positive. MSB bit is 1, so the number is positive. So we get 1. When we'll convert this binary number to a decimal number, we will see we'll getting 1. So again see the theory, what the theory portion is saying, to subtract 2 and bit signed binary numbers. So when we have a signed numbers, where the sign will be considered, unsigned numbers will not have any sign. But in signed numbers, MSB bit matters, that whether it is 0 or 1. When the MSB bit is 0, as I told, it is a positive number, and when the MSB bit is 1, it is a negative number. So we can use ones complement method of subtraction if we have a number in decimal. If we have number in decimal, then first decimal number will convert to the binary number, and then if we want to perform A minus B, then B ones complement will be added to the A. First, the number that we have to subtract B, we take it out as ones complement. I already explained this part. Next, we add the ones complement of the number to the first number A. That is, ones complement of B is now added to A. If any carry bit is generated, like here, the carry bit is generated here, that is 1. Complement the result of step 2. We will complement this result, that is, the result will be equal to the 1. Now, let's take second example also. If we want to subtract 0 1 1 0 base 2 to 0 1 1 1, 0 1 1 0 is equals to what? 4 to 6, and 0 1 1 is equals to 7. If we wants to do 6 minus 7, that is the first number smaller and the second number is greater, then what will happen? The ones complement of B is taken. First, ones complement. What is the value of 7? The binary value of 7 is 0 1 1. So ones complement of 7 is equals to 1 0 0. So ones complement of 7 will be taken, that it will be equal to 1 0 0, because we want to subtract 7 from 6. So ones complement of 7 will be taken. Next, we add ones complement of B to 0 1 1 0. So 6 is 0 1 1 0. 6 is equals to 0 1 1 0 and 0 1 1 0. This is 0 here. And minus 7 is equals to ones complement of 7. And what is ones complement of 7? That is 1 0 0. When we will add 0 0 0, 1 1 1. So we get this result, that is 1 1 1 0. 0 is missing here, that is 0 1 1 0. As no carry bit is generated, here no carry bit is generated. If we no carry bit is generated, we complement this obtained result to understand which number it is. So we have to convert it to the complement, because we need to understand what is the original value of this number. So ones complement of this number is 0 0 1, that is 7. Thus we have answer 1 1 0. Basic answer that we got is our answer 1 1 0. And we understand that the result obtained is minus 1, as we don't have carry. So the result obtained basically is minus 1, because we don't have a carry here. But now we are facing the problem here. What is the problem here? That this is the only disadvantage of ones complement, that we need to add the carry bit. If there is no carry bit, here there is no carry bit is generated, then we have to complement the result to exactly know what is the original value of this result. So when we complement this result 1 1 1 0, then we got it 0, 0, 0, 1. That is equals to 1. But in result, we get MSB bit 1. So it is equals to minus 1. This is the disadvantage of 1's complement. That's why for subtraction, we generally use 2's complement. First, we will understand what is 2's complement. I have already explained 2's complement is always equals to 1's complement plus 1. Why it is considered? Like we want to have there is a number that is 0. Positive value of 0 is always 0 in for 1's complement. In 2's complement, we will see what will be the result. Like in 4-bit, we are having the number in binary form, that is 0. When we want to represent minus 0 using 1's complement, when we want to represent minus 0, what we will do? We will do the 1's complement of the original 0. So we will get here 4 times 1. So we get the wrong answer and we don't get carry here. So what we will do to obtain correct answer, we will reverse the answer that we got in 1's complement. Now what about 2's complement? 1's complement plus 1. That is 1, 1, 0, carry here 1, 1, 1, 0, carry is 1, 1, 1, 0, carry is 1, 1, 1, 0, and the carry is generated. In 2's complement, carry is always neglected. So minus 0 is also represented as 0 in 2's complement. Minus 0 is also represented as 0 in 2's complement. So 2's complement is always a better choice for subtraction. That's why we always prefer 2's complement for subtraction purpose. Whenever we will see that A minus B is given, we will directly do the 2's complement of B. Why we will prefer 2's complement? I have already explained, because in number system we don't have minus 0. But if we want to represent minus 0, if I am saying 7 minus 0, what we will do? We will get the 2's complement of 0 first, then we will add that with 7. So what is written here? Subtraction using 2's complement. To subtract 2 and bit sign binary numbers, we can also use 2's complement method of subtraction. Some steps are given here. First step is we take out the 2's complement of the number B. So whatever be the number, that is A minus B, we will first calculate the 2's complement of B. And then we will add A plus 2's complement of B and we will get our result. That will be equal to A minus B. So that's all about 2's complement. Let's understand with the example. Here we have a number 0, 1, 1, 0, 1. This is equals to A and this is equals to B. We have to perform A minus B using 2's complement. So what will be the 1's complement of B? 1's complement of B is equals to 1, 0, triple 1. 1 will be converted to 0 and 0 will be converted to 1. And what will be the 2's complement of B? Plus 1 will be added. When plus 1 will be added, 1, 1 is equals to 0, carry here 1. 1, 1 is equals to 0, carry again 1. 1, 1 is equals to 0, carry again 1. Or then 1. We get double 1, triple 0. And when we want to do this operation, that is 0, double 1, 0, 1, and then 2's complement is 1, 1, triple 0. 1, 1, triple 0. So 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0, carry here 1, 1, 1, 0 and then 1. So this carry will be neglected and we get 0, 0, 1, 0, 1 as our result. So this is our result. But if we have to subtract 0, 1, triple 0 to 0, 1, 1, 0, 1. Here we have A 0, 1, triple 0 and B is this. So first we will calculate the 1's complement and then we will add 1 to the 1's complement. Then we will get the 2's complement of B. This is the 2's complement of B. When we will add this 2's complement of B to A, we will get our result. So here we get our result is equals to minus 5 in sign form. Why we are saying it is minus 5? Because the sign bit is 1. Now moving to the next topic, subtraction using 10's complement. Subtraction using 10's complement. As when we have decimal number system that has base 10 and we want to do subtraction using decimal number system, then we use 10's complement and 9's complement. For subtraction of any two given signed decimal numbers, we use 9's complement and 10's complement. Basically 9's complement and 10's complement are used for decimal number, as I told. To find out the value of subtraction, first we will understand what we will get using 10's complement. This comes under R's complement category. For two number A and B, we have to subtract B from A, where we have two numbers A and B and we want to perform A minus B. We find out the 10's complement of B. First we will find out the 10's complement of 10's, then complement of B. What will be the 10's complement of B? 10 to the power n minus B. N is equals to the number of digits. What are the number of digits specifying here? Like we have a number 75 base 10 minus 43. So what will be equal to capital N? Here we will count the number of digits in a number, like 43 is in 2 digits. 75 is in 2 digits. So the value of capital N will be equal to 2. So 10's complement of B is 10 to the power n minus B. What will be equal to 10 to the power n? That number 2, that is 10 to the power 2 minus B. B is equals to 43. First we will get 100 minus 43 is equals to 57. And this is equals to the 10's complement of B. Second step will be A plus 10's complement of B. Then we will do A. What is the value of A here is 75 plus what is the value of 10's complement of B, that is 57. What we will get? 132. After adding both the numbers, we will get 132 here. That is given here. Now remove the extra carry bit. So this is a 2-digit number and in result we get 3-digit number. So we will remove the carry. Remove carry. So we get 32 as a answer here. This is the process for 10's complement of a number. Next is subtraction using 9's complement. Here we have 10's complement is 10 to the power n minus B. That is 10's complement. But if we want to add 9's using 9's complement, so what we will do? 10 minus 1 is equals to 9. So 10 to the power n minus 1 is equals to 9's complement minus that number. So this will be our formula here. 9's complement of E is equals to B is equals to 10 to the power n minus 1 minus B. If when we add the 9's complement of B plus 1 to the number A, after this doing this step, we will add the 9's complement of B plus 1 to the given number, and if any carry occurs, we add the carry bit to the remaining generated number, and the result that occurs is our required difference, and we will get the result here. How we will do it? Like we have a number here that is 75 again and 43 again in base 10. So this is a decimal number. So 75 is equals to A and 43 is equals to B, and we have to perform A minus B using 9's complement. Question is given that perform A minus B using 9's complement. So what you will do? In that case, we will first calculate the 9's complement of 43. And what will be the 9's complement of 43 is 10 to the power n. Number of digits in a number is 1, 2. 43, when we will count the number of digits in 43, that is 1, 2. So 10 to the power 2 minus 1 minus 43, because this is B here. What we will get? 10 to the power 2, that is 100. 100 minus 1 is equals to 99. And 99 minus 43 is equals to 9 minus 3 is 6. And 9 minus 4, 5. So 9's complement of B is equals to 56. 9's complement of B is equals to 56. How we get it? Is it clear? The next step, A plus 9's complement, because we want to perform A minus B. So it is equals to A plus 9's complement of B. And here we will get the same result. So what is the value of A here? The value of A here is 75. And 9's complement of B is equals to what? 56. When we will add both the numbers, 5 and 6, 6 and 5, 11, carry here 1, 7 and 5, 12 and 1, that is 13. We get, the number is 75, then we get 131. In last step it is written here if any carry occurs. So here carry occurs, that is 1. 1 is a carry here. So this carry will be added to the remaining number and we get 32 as the 9's complement. So this is the difference. In 10's complement we get 31 as a result. But in 9's complement we get 32 as a result. So that's all about complement of a number. And this is very important. Next is signed magnitude form. Basically, it is a way of representing the numbers. What type of numbers? Signed numbers. Because we have numbers in positive form, in negative form. So, to represent the numbers with their sign, we have a form that is signed magnitude form. It is basically a way of representing signed numbers in binary form. It is similar to the way we represent signed number in decimal. Like we represent minus 13. Similarly, like we represent minus 3. In binary also we represent minus. Like in decimal numbers. Here first bit of the number indicate whether the number is positive or negative. Like we have a number here 1, 0, 0, 0, 1. So this is the MSB bit here. So this MSB bit will represent that this is a negative number because it is 1. But if the digit will be equal to 0, 0, 0, 1. So this number is positive. 0 always represent positive and 1 always represent negative. In the sign magnitude form, the most significant bit of the number is used to indicate the sign. As I told, the leftmost bit is the most significant bit and it will always implement the sign. If MSB is 0, the number is positive, but if the MSB is 1, the number is negative. The remaining bit of the number represent the magnitude. So this bit will represent the sign and these remaining 4 bits will represent magnitude. These 4 bits will represent magnitude here. The magnitude of a number is the absolute value. It will be the absolute value. What will be the value here? 0, 0, 0, 1. So it will be equal to 1 and MSB bit is 0. It will be equal to plus 1. But here it will be equal to 0, 0, 0, 1 and MSB bit is 1. So it will be equal to minus 1. For example, the binary number 0, 1, 1, 0, 1, 0, 0, 1. Represent the positive number, that is 101. Why it is positive? Because MSB is 0. So this number is positive here. The MSB is 0. So the number is positive. The remaining bit represent the magnitude. So in binary, we basically count this place as 1, 2, 4, 8, 16, 32. 1, 2, 4, 8, 16, 32 and 32 baad 64. So when we will add 64, 32, 8 and 1, we will get 101 as our number. We will get 101 as our number. The binary number 1110101 represent negative number because the MSB bit here is 1. It is equals to minus 101 because the MSB is 1 and the number is negative. The remaining bits represent 101. So you can see there is a difference in representation. In positive number, the magnitude is 1101001. In negative number also, the magnitude is 1101001. But there is a only difference between the MSB bit, that is the sign bit. In negative, MSB is 1 and in positive, MSB is 0. That will represent the sign. So that's all for today. In next lecture, we will study adder and half adder, full adder, parallel adder, adder, subtractor. So we will study these concepts in our next lecture. Thank you very much.